Children, welcome to the 18th module. In this video, we are going to summarize what we have learned in this chapter. Children, in this chapter, we have learned about the different reaction of acids and bases, how acids and bases cancel out each other's effects, and many more interesting things that we use and see in our everyday life, etc. we have discussed. So let us begin with acids. We know that acids are sour in taste and they change the color of blue litmus to red. Hydrochloric acid, sulfuric acid, nitric acid, etc. are strong acids, whereas carbonic acid, acetic acid, etc. are weak acids. And acid, no, they can produce H plus ions when they dissociate in water. Then bases are bitter in taste and they feel slippery or soapy when we touch them. And bases, no, they can turn red litmus to blue color. Then in their aqueous solution they can conduct electricity also. Then acids and bases, when they react together, it forms salt and water. That also we have learned, that is neutralization reaction. In neutralization reaction, when acids react with bases, it forms salt and water. So this is very important, neutralization reaction. So you have to remember neutralization reaction thoroughly with example, that is hydrochloric acid when react with sodium hydroxide, it will give you sodium chloride and water. Then we have learned about when acid and metal reacts, it will give you salt and hydrogen gas. Then acid plus base will give you salt and water. Next, acid when it react with metal oxide, it will give you salt and water. Then acid plus metal carbonate will give you salt, carbon dioxide and water. pH scale is the scale for measuring hydrogen ion concentration in a solution. The strength of an acid or an alkali can be tested by using a scale called the pH scale, and the value begins from 0 to 14, which gives the measure of hydrogen ion concentration in a solution. A neutral solution has pH value 7, while an acidic solution has a pH value less than 7, and a basic solution, no, which is having pH value more than 7. Next, we are going to discuss about the chemicals from common salt. We know that the combination of hydrochloric acid and sodium hydroxide will give you sodium chloride, and this sodium chloride we used in food. Then common salt enriches the flavors of food, it helps our nervous system. Then production of hydrochloric acid in stomach, movement of muscles, etc. It is also used as preservative in pickles, fish and meat. It is used in the manufacture of soap. Then it used to melt ice from roads in cold countries. Then it is a raw material for the manufacture of other compounds like sodium hydroxide, that is NaOH, NaHCO3, then sodium carbonate, Na2CO3, and bleaching powder, that is CaOCl2. Do you know how we are obtaining this sodium bicarbonate? Yes, we are obtaining this sodium bicarbonate from sodium chloride, water, carbon dioxide along with ammonia, and it will give you sodium bicarbonate and ammonium chloride. Is it useful, this baking powder? Yeah, it is really useful. Okay, we know that the soda commonly used in the kitchen for making tasty crispy pakoras is actually baking soda. So in baking industry, we are using this sodium hydrogen carbonate widely for baking cakes, etc. We are using this sodium bicarbonate. Okay, and this sodium bicarbonate, no, actually it is a mixture of baking soda and mild edible acid. We are calling it as tartaric acid. So actually this baking powder, it is a mixture, that is a baking, not baking soda, baking powder. It is a mixture of baking soda and mild edible acids called tartaric acid. Then it is also used as an antacid, that is antacid, no, which reduces the acidity in our stomach. Then it is a fire extinguisher also. It is used as a fire extinguisher. That is, you might be seeing this in theater as well as laboratories, etc. Then, do you know how these glasses are made up of? Yes, it is made up of using sodium carbonate. Okay, so sodium carbonate, how we are obtaining? That is, on when you heat sodium bicarbonate, you will obtain sodium carbonate, carbon dioxide, and water. Then this sodium carbonate, no, when treated with water, it will give you sodium carbonate decahydrate, and that we are calling washing soda. So that is also useful for us, and it is used to manufacture cleansing agents, soap, glass, and paper. Okay, then to remove the permanent hardness of water, we are using this sodium carbonate. Okay, so it will helps to make the water soft. Then to manufacture sodium compounds like borax, etc., no, we are using this sodium carbonate. So these are the main use of sodium carbonate. So sometimes, no, you may feel itching when you play with seawater, but it doesn't happen when you swim in a pool. Why does this happen? Yeah, actually, no, the swimming pool, actually it is treated with a bleaching powder. So actually it helps to kill the bacteria, germs, etc. present in the water. Okay, but what about in seawater? Seawater contains many salts, so you may feel itching. Okay, so bleaching powder, no, it helps to disinfect water. Okay, so these are about bleaching powder. So it also helps to bleach wood pulp, disinfect drinking water, etc. Okay, next is about water crystallization. It is the fixed number of water molecule present in one formula unit of a salt. So we know that gypsum is an example for the molecule which contain a fixed number of water molecule. So here on heating gypsum at 373 Kelvin, it loses water molecule and becomes calcium sulfate hemihydrate. This is called plaster of Paris, the substance which doctors use as plaster of Paris for supporting fractured bonds in the right position. When you mix this plaster of Paris with water, it again give you gypsum, that is CaSO4 half H2O plus 1 and half H2O will give you CaSO4 2H2O. So these are about our second chapter. Thank you so much for watching this video. Stay home, stay safe. Once again, thank you.